Adding and subtracting complex numbers graphically. Well, that kind of speaks to the objective, which is the same thing. Add and subtract complex numbers graphically. So before we begin, what do we know? Well, we know what a complex number is. A combination of a real number and an imaginary number. It's made up of a real part, which in this case is the A, an imaginary part, which is the B, and the imaginary unit, which is the square root of -1. I in mathematics, J in your technical fields. And we mentioned this is the standard or the rectangular form. Rectangular because we put it onto a rectangular graph. We know that complex numbers can be represented by a vector from the origin to a given point on the complex plane. And since we know it can be represented as a vector, we know some things about vectors. When two vectors are tail to tail, they can be added graphically using the parallelogram method. And vector subtraction is done by adding the opposite. All right, so let's put this to work and do some examples. Example 1, add 1 plus 2j and 3 plus j graphically. Then we're going to check our results mathematically. Okay, I'm not going to be too fancy. Let's see here. I will attempt to freehand this reasonably well. As a reminder, in the complex plane, the x-axis is the real axis, and the y-axis is the imaginary axis. Okay, I'm going to kind of go across. If I can evenly space these without a ruler, I think I'm pretty good. And do the same thing here. Okay, hope that's going to work out all right. Let's first plot 1 plus 2j's vector and 3 plus j as a vector. 1, and this would be 2. So we'll put a point there, and this is the vector 1 plus 2j. 1 plus 2j. And 3 plus j, well, 1, 2, 3. There's a 1, of course, the coefficient of the j. There's a 1 there. We don't write it, so let's put the 3 plus j vector into here. That's pretty close. And let's add them up using the parallelogram method. Well, I know the answer, so I need to try to make this, I want to go up. I want to go up, let's see, I got to go up this much. Okay, and I'm going to go over this much. So I created a parallelogram. I did the same thing on the right over here as I did on the left. And I did the same thing above as is down here below. And the parallelogram method says we now go from the origin up to the opposite side of the parallelogram. I forgot to note this one was 3 plus j, and that is the sum of those two vectors. It happens to be at 4 plus 3j. So the sum of the vectors is 4 plus 3j. Mathematically, perhaps you'll recall how to add complex numbers mathematically. You simply add the real parts. Okay, so the real part is 1 plus 3. And then you add the imaginary part. Well, that's 2 plus 3. And then you have your imaginary unit, which is the j. And so, as you can see here mathematically, 4 plus, and I made a mistake. This is not 2 plus 3. This is 2 plus 1. Sorry about that. This is 2 here, and that's a 1 here. I goofed. This is 2 plus 1. So there is 4 plus 3j. Sorry about that. Okay, so that's added graphically, and then adding and checking mathematically. So let's do the same thing here for example number 2. Given the complex number 1 minus 2j, subtract its conjugate graphically. Okay, so I'm straighten up here. Okay, well, first off, our number is 1 minus 2j. Okay, let's note its conjugate. conjugate. The same two terms with the opposite sign between them. So if the number is 1 minus 2j, the conjugate is 1 plus 2j. And now, let's do this. Well, hang on a second. Let's take a look. We want to, when we subtract, we want to add the opposite. So we're saying take the number 1 minus 2j, and I often like to put the number in parentheses to kind of give it a sense of that this is one single number. And we want to subtract its conjugate. Its conjugate is 1 plus 2j. Okay, so we know that vector, let's go back up to here and remind ourselves that vector subtraction is done by adding the opposite. So come back down to here. Vector subtraction is done by adding the opposite. So this is 1 plus 2j plus the opposite of this. The opposite of this is negative 1 minus 2j. Okay, so we're going to add the opposite. Okay, vector subtraction is adding the opposite. So we have two vectors we want to add, and we'll use the parallelogram method. Okay, let's see here. Whoops, and I made another mistake. I was looking at my work and then realizing this should be a minus. My goodness, I'm 2 mistakes in. It's only been 7 minutes. So 1 minus 2j plus. Okay, looks like I'm going to be in the lower half of the complex plane. So I'm going to go ahead and set myself up. This is all going to take place in quadrants 3 and 4. And I know that because positive, negative, and negative, negative is quadrants 3 and 4. As a reminder, this is the real axis, and this is the imaginary axis in the complex plane. Okay, 1 minus 2j. Well, there's 1. 1 in the real, negative 2 in the imaginary. I'll put a little point here to get myself situated, and I'll draw the vector to here. So this is 1 minus 2j. Negative 1 minus 2j, okay. Here's negative 1, here's minus 2j. So I'll put that vector here. So this is negative 1 minus 2j. And then I'll add them, okay. And adding them, of course, means we'll make a parallelogram. So I'm going to go... We'll go down to, and I know it's going to work out. So here is, I'll draw that one over here. I'll draw this one over here. And the origin to the opposite point, this is the resulting vector when I add those two together. And this vector is 0 minus 4j. And I want you to notice that even when you're writing a number in complex form, if the real portion is 0, you often still write 0. You don't have to. You might just write it as minus 4j. But you should know there's a 0 there. Okay, so that's how you would do it using the parallelogram method. Again, subtracting vectors is the same as adding the opposite mathematically. 1 minus 3, whoops, that's my third mistake today. Again, sorry about that. 1 minus 2j minus the conjugate, which is 1 plus 2j. Well, we do the real parts and the imaginary parts. 1 minus 1 is 0. Negative 2j minus positive 2j is the same as negative 2j minus 2j, which is negative 4j. So there's the same answer mathematically. So there you have it, adding and subtracting complex numbers graphically.